In last week's video, I mentioned that we would be going over titration calculations, so let's jump straight into it. By titration, you find that 50 cubic centimeters of hydrochloric acid neutralizes 25 cubic centimeters of 0.100 mole per cubic decimeter of sodium hydroxide solution. Calculate the concentration of hydrochloric acid. The first thing we would do is to make a note of all the useful information given by the question. So for hydrochloric acid, we have the volume here, which is 15.0 cubic centimeters. And for sodium hydroxide, we have both the concentration and the volume. Moving on from there, our first step is to write a balance equation. So we know that sodium hydroxide reacted with hydrochloric acid and it produced sodium chloride and water. This equation is already balanced. A balanced equation is useful for calculating moles, as you will see a little later on. Now that we have our equation, we can move on to step 2, which is calculating moles. As you may remember from the previous video, a useful memory aid for these types of calculations is this triangle here. Now the N here means the number of moles, C is the the concentration, while V is the volume. Remember also that this horizontal line means that you have to divide, while this vertical line means that you must multiply. Okay, so we want to find the number of moles. You simply place your finger on the N, which is number of moles, and you'll be left with concentration and volume. And since they're separated by a vertical line, which means that in order to get moles, you must multiply the concentration by the volume. And we've written the equation here. Moles, and the unit is mole, is equal to concentration, mole per cubic decimeter, by volume, which is in cubic decimeter. Now, before we plug in these values here, you can see that the volume here is in cubic decimeters, while the volume here is in cubic centimeters. Now, when we're doing these types of calculations, we always use the volume unless specified otherwise in cubic decimeters. So what we need to do is to convert this volume here into cubic decimeters, and that is simply done by dividing this volume by 1,000. So instead of 25, we get 0.025 cubic decimeters. So now we can go ahead and plug in the values. So now that we know the number of mole of sodium hydroxide, we can use the number of mole to figure out the moles of hydrochloric acid. We do this by looking at this balance equation here, and it tells us that 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. So the mole ratio is equal to 1 NaOH, 1 HCl. Now we already figured out the moles of sodium hydroxide, so we know that is 2.50 by 10 to the negative 3 mole. So we can safely say, since it's a 1-to-1 ratio, that the number of moles of hydrochloric acid is the same number of moles as sodium hydroxide. So the last thing we're going to do is we're going to calculate the concentration of hydrochloric acid. Now we're going to go back to the memory aid right here, and this time we want to find the concentration, so we put our finger on the C and we're left with N, the number of moles, and V, the volume. And since they're separated by the horizontal line, we know that concentration then is equal to the number of moles, and we divide that by the volume in cubic decimeters. Now, if you look here, however, you'll see that the units here are cubic centimeters. So in order to convert those to cubic decimeters, we divide by 1,000, and we get 0.015 cubic decimeters. So now we have both the mole and the volume. We can plug in those values. 2.50 by 10 to the negative 3 mole. We're going to divide that by 0.015 cubic decimeter. And your concentration is going to be mole per cubic decimeter. So it's going to be 0.167 and the units here. So here is the concentration of hydrochloric acid, and that is what the question asks. Question says, a standard solution of sodium hydroxide was made by using 1 gram of sodium hydroxide in 250 cubic centimeters of solution. From the solution, an aliquot of 25 cubic centimeters of sodium hydroxide was pipetted and transferred into a conical flask. 23.50 cubic centimeters of sulfuric acid was required to neutralize the base. Calculate the concentration of sulfuric acid in grams per cubic decimeter, mole per cubic decimeter, and mole per liter. So we know right away that we have to do 3 types of concentration. So the first thing we're going to do, like before, is to write down all the pertinent information. So we have sodium hydroxide here. And for the sodium hydroxide, we know the mass, which is 1 gram. We know the volume of the original sample is 250 cubic centimeters. And we also know the volume of the aliquot, which is 25 cubic centimeters. And for the sulfuric acid over here, we know the volume. So the next thing we're going to do, and we're following the same pattern as before, is to write a balance equation for the reaction. So I'm just going to move this up a bit so we can get a better view. So we know that sodium hydroxide reacted with sulfuric acid, and that reaction produced sodium sulfate and water. This equation, however, is not balanced, so we're just going to go ahead and balance the equation. So this equation tells you that 2 moles of sodium hydroxide neutralizes 1 mole sulfuric acid. So the second thing we're going to do is we're going to calculate the moles of the base. Now take a look at the information over here. Is there any way we can calculate the number of moles from this given information? Now you might have recalled in the previous video that we also calculated moles using this triangle here. So mass was here, mole was here, and right here you had your molar mass. Again, the horizontal line means that you must divide, and the vertical line means that you must multiply. So we can use this equation here, where moles here is equal to mass here, and mass is given in grams, and we divide that here by the molar mass. And the molar mass is given in grams per mole. So we already have the mass of the sodium hydroxide and the molar mass, which I had worked out before. It's 39.997 grams per mole. And if you don't remember how to work out the molar mass, you can take a look back at my previous video. So we're just going to plug in the values. 1.0 grams, and we're going to divide that by 39.997 grams per mole. This is going to cancel out, leave mole, and you're going to be left with 0.0250 mole of sodium hydroxide. Now, if you figured that the next step would be calculating the moles of the acid, you would have been correct. But before we do this, let's take a look at the question again. So the question says that 1 gram of sodium hydroxide was used to make up 250 cubic centimeter solution. 25 cubic centimeters of this solution was then taken out and used in a reaction with sulfuric acid. So let's look at a visual representation over here. So you had 1 gram of the solid, you then added water and made up a solution of 250 cubic centimeters. From this 250 cubic centimeters, you took out 25 and placed it in a conical flask. This 25 cubic centimeters of the sodium hydroxide was then reacted with the sulfuric acid. So when we calculated the moles from the mass of the sodium hydroxide, we were calculating the moles in the 250 cubic centimeter solution. However, we want to know the number of moles in the 25 cubic centimeter solution. So that is what we need to find out before we move on. So the easiest solution to this problem is using the conversion factor, and I'm going to take you through this slowly. So you know that we originally had 250 cubic centimeters of solution, and you know that the number of moles that we found out was 0.0250 mole. However, we want to find the number of moles in 23 centimeters cubed. So all we are going to ask ourselves is, how do we get from 250 to 25? So we're going to divide the two values and we get to 10. So in order to go from 250 to 25, we would divide by 10. So we apply that same logic to the number of moles. And we say to arrive to the number of moles in 25 cubic centimeters, we will divide this value by 10. And our new number of moles is, so this is the number of moles in 25 cubic centimeters, and this is the value that we want. So now that we know this value of sodium hydroxide, we can go on to the third step of calculating the number of moles in the acid. And you know that we would do that by using the balance equation. So from above it says that 2 mole of sodium hydroxide is equals to 1 mole of sulfuric acid. That means that if we have 0.0025 mole of sodium hydroxide, then we will have 0.025 divided by 2. Sorry, that was supposed to be 0.0025 divided by 2 moles of sulfuric acid. And if you put that into your calculator, you should get 0.00125 mole of sulfuric acid. So that's the number of mole you have. So we're just going to refer back to our triangle, because the next step we're going to try to calculate is to find the concentration of the sulfuric acid. So again, we're trying to find the concentration. So we're going to look at number of moles and volume when they are separated by the horizontal line, which means that we must divide. So let me just write the equation here. Remember to write your units. And we're going to divide that by the volume.
cubic decimeters. So now we will just plug in the value, the moles of sulfuric acid, 0.00125 mole, and we're going to divide that by the volume, and the volume of sulfuric acid was 23.50. So we're going to divide 23.50 cubic centimeters by 1,000 to get cubic decimeters, and that's going to be 0.02350 cubic decimeters. So when we divide those two numbers, we get 5.3 by 10 to the negative 5 mole per cubic decimeter. But mole per cubic decimeter is not the only unit that the question asks us to find the concentration in. It also asks us to find the concentration in grams per cubic decimeter as well as mole per liter. So we already completed this one, so we need to find the other two. So we're going to find the concentration of sulfuric acid in grams per cubic decimeter next. And all you have to do for that is multiply this value here by the molar mass of sulfuric acid. So we can say concentration, I'm going to move this up here, concentration in grams per cubic decimeter is equals to 5.3 by 10 to the negative 5 mole cubic decimeter, and we're going to multiply that by 98 grams per mole. Now if you look at the units, you see that it actually works out because we're going to remove the mole and we're going to be left with, yes. So the answer for that is 5.21 grams per cubic decimeter. And the final concentration we're supposed to find is mole per liter. So looking at this, we know that we need mole and we need the volume in liters. So we already know that the volume given was 23.50 cubic centimeters, so we need to convert that into liters. And how do we convert that into liters? Well, we divide by 1,000. So basically we do the same thing as we do for converting into cubic decimeters. So the answer would be 0.02350 liters. So when you plug that in, we get 0.00125 mole. And we're going to divide that by 0.02350 liters. And we're going to get the same answer as above because they're the same values, by 10 to the negative 5 mole per liter. Answer. Now let's try this question. 25 cubic centimeters of iron sulfate of concentration 0.100 was acidified with an equal amount of dilute sulfuric acid and then titrated with potassium manganate solution. It required 20.60 cubic centimeters of potassium manganate solution to reach the end point of titration. Find the concentration of potassium manganate solution. Now, I've already written down the pertinent information. For iron, we have the volume and the concentration, and for manganate, we have the volume alone. So now that we have all that information, the next thing to do would be to write the balance equation. So this is the equation here, and I'm just going to go ahead and balance it. If you look at the question above, you will see that the iron sulfate reacted with the dilute sulfuric acid, and the dilute sulfuric acid then reacted with the potassium manganate. So this says that 5 mole of the iron neutralizes 8 moles of the sulfuric acid, and the H here represents the sulfuric acid. The equation also tells you that 8 moles of the sulfuric acid is equal to 1 mole of the permanganate. The second thing we're going to do is to calculate the moles of the iron. And remember, we're going to calculate the moles of the iron because we have the concentration and we have the volume. And if we're referring to this triangle here, this memory aid, remember that the number of moles is equal to concentration by volume. So we're going to go ahead and calculate of iron. We're going to write the equation here. Moles is equals to concentration by volume. And again, because the volume is asked in cubic decimeters, we have to convert this to cubic decimeters. So we know the number of the concentration is 0.100. And when we convert 25 cubic centimeters into decimeters, we get 0.025 cubic decimeters. And that leaves us with the number of moles. So now that we have the moles of iron, we can move on to finding the moles of sulfuric acid. So we're just going to move that up here. So we're going to find the moles. And from this little equation here, it tells us that 5 moles of iron is equal to 8 moles of sulfuric acid. And we just found out the moles of iron to be. And therefore, our moles of sulfuric acid would be 8 divided by 5, and we're going to multiply that by 0.0025 mole. And that's going to give us 0.004 mole. So now we know the mole of sulfuric acid. We can move on to this point here, which tells us that 8 moles of sulfuric acid neutralizes 1 mole of permanganate. So this is part A to number 3, and we can go on to part B, which states that, let me write this in a different color, 8 moles of sulfuric acid equals to 1 mole of permanganate, and we just figured out the moles. We just figured out the moles of sulfuric acid, which was 0.004 mole. So then we know that the number of mole of magnet is 0.004, and we're going to divide that by 8, and that is going to give us 5.0 by 10 to the negative 4 mole of permanganate. So now we have the mole of permanganate. What are we going to do now? We're going to go through the final step, and that is to find the concentration of permanganate. So we have the number of moles here. We just found out 5.0 by 10 to the negative 4 mole. And if we go back way up to the beginning, we have the volume. So we're going to write the volume is equals to 20.60 cubic centimeters. And to change that into cubic decimeters, we're going to divide by 1,000 to get 0.0206 cubic decimeters. Okay, so going back to the triangle here, we want to find concentration this time. So we know that concentration here is equals to number of moles divided by volume. So concentration of permanganate moles is equal to number of moles 5.0 by 10 to the negative 4 mole. And we're going to multiply that by 0.0206 cubic decimeters. And we're going to divide that, divide. So that's supposed to be divide. And that's going to be 0.024 mole cubic decimeter. And that's your answer. This next question says 8.23 grams of iron salt was dissolved in 250 cubic centimeters of pure water. 25 cubic centimeters aliquots were pipetted from the stock solution and titrated with 0.0200 mol cubic decimeter potassium manganate. The titration values obtained were 23.95, 23.80, and 23.85 cubic centimeters. Now it wants you to calculate the total mass of iron in the original sample and to calculate the percentage iron in the salt. Now I've already written down the pertinent information that the question has given you. So for iron, we have the mass, we have the volume of the original sample, and we have the volume of the aliquot. For manganate, we have the concentration, and we were given 3 volumes. So what we do is take the average of the volumes, which was 23.87. Now, as usual, the first thing we're going to do is write a balance equation. So add in an 8 here, a 5 here, and a 5 here would make this equation balance. So that means we can move on to step number 2, which is to calculate and we choose to calculate the moles of manganate because we have both concentration and volume. And again, referring to the triangle here, we should know by now that the number of moles is equal to concentration multiplied by the volume. So again, we can go ahead and write that equation, moles, and the unit is mole, is equal to concentration in mole per cubic decimeter. We're going to multiply that by the volume in cubic decimeter. So we're just going to plug in those values next, and we have 0.0200 mole per cubic decimeter. And the volume here is 23.87 cubic centimeters. So we're going to convert that into cubic decimeters by dividing by 1000, and we get 0.02387 cubic decimeters. And when you multiply that, we get 4.77 by 10 to the negative 4 mole. So what we're going to do next is to find the moles of iron. So step 3 is to find the moles of iron. And we have all the information here for iron, but we're going to find the moles of iron using the balance equation here. So this balance equation tells us that 1 mole of permanganate is equal to 5 moles of the iron. So then we know that 4.77 by 10 to the negative 4 mole of permanganate is then equal to 4.77 by 10 to the negative 4 mole, and we multiply that by 5 to get 2.387 by 10 to the negative 3 mole of iron. Now the 2.387 by 10 to the negative 3 moles of iron is the number of moles that reacted with the permanganate. Now if we go back to the question above here, it says that 25 cubic centimeter aliquots of the iron. So this number of moles that we found down here was the number of moles in the 25 cubic centimeter. But the question asks for us to find the total mass of iron in the original sample. And the original sample, as you see here, is 250 cubic centimeters. So our next goal then is to find out the number of moles of iron in the 250 cubic centimeters. So we know we want to get from 25 to 250 cubic centimeters. So how do we get from 25 to 250? If we divide 250 by 25, we get 10. So in order to get from 25 to 250, we multiply by 10. And we do the same for the number of moles. So we're just going to multiply 2.387 by 10 to the negative 3 by 10. And we're going to get out 0.02387 mole. So this is the number of mole in the 250 cubic centimeter sample, and that's the number of moles that we want to use. So finally, that question asks about the total mass of iron. So in order to find the mass, we're going to use this triangle right here. Mass, mole, and molar mass. So we know that the horizontal line means that you have to divide, and the vertical line means that you multiply. So if we're trying to find the mass, we look at the moles and the molar mass, and then we can tell that mass is equal to mole multiplied by molar mass. So our fourth goal down here, calculate the mass of iron. And we're going to write the equation, which is mass in grams is equal to moles by molar mass. Going to move that up a bit. So the moles are 0.02387 mole, and the molar mass of iron is 55.8 grams per mole. And we just, moles are cancelled out. We're left with grams, and then we get 1.332 grams. But the question doesn't stop there. It also asks for you to calculate the percentage yield. And as you recall from our previous video, that's equal to the actual yield. And we're going to divide that by the theoretical yield. And we're going to multiply that by 100. So we know that we have the actual yield here, but where do we find the theoretical yield? And that is easy. If you go back up here, you wrote down the theoretical yield, which was 8.25 grams. So we have both values. So we divide 1.332 grams, and we're going to divide that by 8.25 grams and multiply that by 100 to get the percentage yield, 16.1%. Let's look at this next question. A solution is made up by dissolving 5 grams of impure sodium hydroxide in water and making it up to 1 cubic decimeter of solution. 25 cubic centimeters of this solution is neutralized by 30.3 cubic centimeters of hydrochloric acid of concentration 0.102 mole per cubic decimeter. Calculate the percentage purity of the sodium hydroxide. So as before, we write down all the useful information, and for sodium hydroxide, we have the mass, the molar mass, the volume of the original sample, and the volume of the aliquot. For hydrochloric acid, we have the concentration and we have the volume. So next, we're going to go on and write the balanced equation. And this equation that I have written here is already balanced. So we can move on to step 2, which is to calculate the moles of hydrochloric acid. And the reason we're going to calculate the moles of hydrochloric acid is because we have both the concentration and the volume. And as you should know by now, the number of moles is equal to concentration by volume. But if you need to remember, and if you need a useful memory aid, you can always use the triangle here.
So moles is equal to concentration in moles per cubic decimeter by volume in cubic decimeter. So we already have the values here, so we're just going to plug those in. And since they're asking for the volume in cubic decimeter and we have it here in cubic centimeters, we're going to divide by 1,000 to get the value in cubic decimeters. So the mole of hydrochloric acid is 3.0 by 10 to the negative 3. And now that we know the number of mole of hydrochloric acid, we can go on and find out the number of moles of sodium hydroxide. As you can see above here, there's a 1-to-1 ratio. So 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. So that should tell us that 3.06 by 10 to the negative 3 moles of HCl is equal to 3.06 by 10 to the negative 3 mole sodium hydroxide. Okay, so if we go back up to the question, we will see that 25 cubic centimeters of the solution is neutralized by 30.3 cubic centimeters of hydrochloric acid, which means that the number of moles of sodium hydroxide that reacted with the HCl was 25 cubic centimeters. However, the volume of the original sample was 1.00 cubic decimeters, or we can convert that into cubic centimeters so that the units are uniform. So we're going to go with 1,000 cubic centimeters. And you can go either way. You can convert the 25 cubic centimeters into decimeters, or you can convert the cubic decimeters into cubic centimeters. At the end of the day, it's still going to be the same value, same conversion factor. So we want to know how to get from 25 cubic centimeters to 1,000 cubic centimeters. So we divide 1,000 by 25 and we get 40. So we know that in order to get from 25 to 1,000, we have to multiply by 40. So in order to get to the number of moles in 1,000 cubic centimeters, we're going to multiply the number of moles in 25 by 40. And we're going to get 0.1224 mole. So that is the number of mole in the original 1,000 cubic centimeters, and that is the number of moles we're going to work with. Okay, so the question asks for you to calculate the percentage purity of the sodium hydroxide. So you know that we have to find the mass first, and then we have to divide the actual yield by the theoretical yield. So we're going to go ahead and find the mass of sodium hydroxide. And we're going to draw our little triangle over here. Mass is up here, mole here, and molar mass. So we know in order to find the mass, we have to multiply the mole by the molar mass. So our number of mole is 0.1224 mole. And we are going to multiply that by 39.997 grams per mole. Like units will cancel out, so we're left with grams. And the number of grams we're left with is 4.90 grams. So now we're going to go on to write the percentage purity. And we know that this here is the actual yield. So it is 4.90 grams. And the theoretical yield, we wrote it down at the beginning. It's 5.0 grams. and we're going to multiply that by 100, and that is going to be equal to 98%. So that is your percentage purity. Let's take a look at this next question. A sample containing ammonium sulfate was warmed with 250 cubic centimeters of 0.800 mole per cubic decimeter sodium hydroxide solution. After the evolution of ammonium has ceased, the excess of sodium hydroxide was neutralized by 85 cubic centimeters of hydrochloric acid of concentration 0.500 mole per cubic decimeter. What mass of ammonium sulfate did the sample contain? I've already written the useful information we're going to need to make the calculations as well as the reference triangle. I then proceeded to write the two balance equations because there are two reactions that's taking place here. First, the ammonium sulfate reacted with the sodium hydroxide, and then the sodium hydroxide went on to react with the hydrochloric acid here. Okay, so looking at this information, we're going to go ahead and we're going to calculate the number of moles of hydrochloric acid. And as you should know by now, moles is equal to concentration in moles per cubic decimeter, and we're going to multiply that by volume in cubic decimeters. So we have that information here. We have 0.800, and we're going to just quickly convert the volume into cubic decimeters from cubic centimeters, and you know you have to divide by 1,000, so we get 0.085 cubic decimeters, and the number of moles here is 0.0425 mole. Okay, so this is the reaction we're looking at, the second reaction here. And since we're looking at that, we can go ahead and find out the number of sodium hydroxide next by looking at this balance equation. So I'm just going to move this up here. And so goal 3 is to find the moles of sodium hydroxide. So since it's a 1-to-1 ratio, 1 mole of sodium hydroxide, NaOH, is equal to 1 mole of HCl. We already know the number of moles of HCl as calculated above. So then, since it's a 1-to-1 ratio, we get 0.0425 moles of sodium hydroxide. The number of moles that we have calculated here is the number of moles that reacted with hydrochloric acid. So it relates to the second balance equation. But remember that the sodium hydroxide also reacted with ammonium sulfate. So we know the number of moles of sodium hydroxide that reacted with the hydrochloric acid, but we don't know the number of moles that reacted with the ammonium sulfate. Now, if we go back up here, we would see that we can also calculate the number of moles from this given information. Would this be the number of moles that reacted with ammonium sulfate? No, it would not be. It would be the number of moles in the original sample. That is, before the reaction took place. So the first thing we're going to do is we're going to use this information to calculate the moles of the original sample. So we know that moles is equal to concentration, which is 0.800 mole per cubic decimeter. And we're going to quickly change the volume to cubic decimeters, which will be 0.25. And we're going to get 0.200 mole. This means that originally you had 0.200 moles of sodium hydroxide, and then you took 0.0425 mole to react with the hydrochloric acid, which means that these two values subtracted from each other, which is 0.0425 0.1575 mole is the number of mole that reacted with ammonium sulfate. So this right here is the value that we need. So now that we know the mole of NaOH that reacted with ammonium sulfate, we can go ahead and try to figure out the number of mole of ammonium sulfate. And we can do that from this first balance equation here. So from the equation, it tells you that 1 mole of the sulfate is equal to 2 mole of the sodium hydroxide. Now we know that the mole of sodium hydroxide is 0.1575 mole. So in order to get the mole of ammonium sulfate, we have to divide this value by 2. Now when we divide the value by 2, we get 0.0788 mole. So there we have the mole of ammonium sulfate. We can't stop there, however, because the question asks us to calculate the mass of ammonium sulfate. So we're going to use this triangle here for a reference point. And mass is here, moles are here, and molar mass is here. So we want to find a mass, which means that we had to multiply the moles by the molar mass. Now, we can write the equation mass in grams is equal to moles, and we're going to multiply that by molar mass in grams per mole. And we're going to plug in the values, 0.0788, and we're going to multiply that by the molar mass, which is 132 grams per mole. And the mole unit is going to cancel out to leave you with grams, and you're going to be left with 10.4 grams of sodium sulfate. So there is your answer.